Hello, everybody. We're going to get started here in just a few moments, okay? Okay, so we're live.
It's just really hard. It's gotta have like the history with that person.
Oh, okay. Oh, okay. Are you gonna put this thing?
No, it's not.
Okay.
So,
but we're a consulting firm based out of Addison. We do a lot of data work, cloud native work, custom development, really whatever the clients want, right? But we're hiring, so if you want to check that out, evolv.com/join. So we've done some cool work with Web3 here. We work with Sentry Labs here local in this area. Do some interesting NFT stuff with Data Connected, and we're always looking for more. So if you want to check us out, we're here.
Definitely appreciate it. And next slide. So we're big on our mission statement to make Web3 accessible to all through multi-dimensional learning experiences in a value-driven communities. So if you've been around us for any sort of time, we're very community-driven. So that's all we do is in-person events. So and learning through education. So if you're trying to get more information about that, see one of us, Nick or I or Jonathan. Yeah, he's definitely someone who's been around for a while. So anybody who's been around for a while kind of knows how we work. So big thanks to one of our partners, CryptoSteel. So pay attention through the today's presentation by Ryan, the other Ryan, better looking Ryan. Not sure. So I will be raffling or giving away a CryptoSteel. So if you know anything about Web3 and safety and not giving up your seed phrase, this is one of the solutions. So at the end, we'll be doing a POAP. If you don't know what POAP is, it's basically proof of attendance. So it's a website. All you have to do is provide your email, and if you continue doing our events, you'll see we do a POAP every time. It's an NFT. It's on a blockchain, and you'll be able to keep track of it.
All right, we get started. Bring up one.
I'd like to thank Ryan for doing a presentation along with some of his colleagues about talking about learning about AI. Because I need to learn about AI, and it's an up and coming space. So thank you, Ryan.
Yeah, and thank you, Ryan. So, thank you guys all for coming. Thank you, Nick, for letting me present it to Vita. So, raise your hand in here if you're already using ChatGPT. Okay, most of the room. That's awesome. All right. Raise your hand if you have a ChatGPT Plus account. Okay, about the other half of the room. All right. Raise your hand if you've interacted with ChatGPT plugins. Okay, so now about a quarter of the room. Raise your hand if you've used the search feature big on ChatGPT. Okay, same. All right, I just wanted to give an idea of how everybody's interacted with and what we're going to be talking about so far. Okay, so Nick said the button's down. Nick, am I good?
Yeah.
Okay, cool.
Oh, click here.
There we go. All right, so it's kind of younger or better, a little bit tangy. My name's Ryan Eggleston. I am a software developer at a company called Form.io. It's a dynamic building company, and as you're building Form, you're generating RESTful APIs underneath. We have customers that are large enterprise customers and do have data entry teams and have software development teams, and then we usually have their software development team the form and hand it off to a data entry team. So that's what I'm currently doing.
Oops. Go ahead.
Okay. Yeah.
I just have to get out of presentation. Sorry.
You're good.
First time I'm doing this. You keep going on yourself.
Okay, perfect. So, a little bit about me. I'm not a machine learning engineer. I am more obvious. And I've got myself in a lot of situations. I know being in and then learning a lot in those situations and try to learn as much as I can and try to, not try to find situations. So I'm a software developer. I started probably in 2016. I was working for a family company and a lot of physical work outside pretty much 2 days here in Arizona, and I wanted to do something different. So I taught myself code, and it's been ever since. I have a friend that this is kind of the story. This is how I got here. I had a friend that two friends that essentially started a crypto mining company. They had a different process called two-phase immersion that they want to utilize in order to increase the performance of the infrastructure that they were using and mine Bitcoin with this process. The process is essentially you take all of your infrastructure, submerge it in what's called dielectric bath. It's a non-conductive fluid. Feels a lot like rubbing alcohol, and it evaporates really easily. But what ends up happening is you store your server in a closed system, and as the servers heat up, they turn the fluid into vapor. And you run copper condenser coils above the vapor, and the vapor will get from the coils and then turn back to the bath and pass a cooling state. And we were doing this for a Gen 1 crypto mining operation. And I started with them just putting crypto servers together and putting them in these large industrial machines. And I didn't want to do that for the whole time I was there, and so I figured I would start learning as much software as I could and start trying to learn how to build software for the management of this infrastructure. So that's 2 days liquid immersion. It's kind of a really expensive way of doing it. You do get a lot of efficiencies out of your infrastructure. And then they started with crypto. We were doing 2-phase immersion. They pivoted to doing asset interchange, and then we ended up pivoting to doing single-phase immersion on crypto mining. It was a lot more cost-effective for enterprise customers. engineers. And so, yeah, that's kind of me getting out from behind the computer. And also, I've been really fortunate to meet Nick, and I've driven a lot of my inspiration for my meetup from his meetup, and gave me a lot of the confidence to feel like I could accomplish this, and that I would have people in the space to rely on that would help me be successful. So enough about me. We can jump into what is artificial intelligence. Artificial intelligence. Artificial intelligence is the ability to have machines mimic human intelligence. It's a very broad term in the sense of what the topic is, and it could be, the way to think about it is to try to learn all of the subsets of that topic and then drill down from there. And a lot of people are very curious to wonder, well, is this going to take my job? Is this thing sentient? Does it have its own consciousness? And it's funny because I feel like since I've been digging into it, and I feel like this happens a lot, is that everybody has to shift their focus of what they actually believe what consciousness is. And more recently, and that kind of will explain, I might be jumping ahead a little bit, but LLMs are essentially, large language models, are essentially using a process called linear regression to predict the next word in a sentence. So if you have a sentence that is, the cat sat, it's like Mad Lib. If you have a sentence where the cat sat on, well, there can only be a small amount of finite words that could actually fit into that sentence. So the cat sat on the rug, the cat sat on the mat, the cat sat on the stool. And so what the LLM does is it uses prior existing context to try to predict what that result should be. And if you don't give it enough context up front, you'll get what's called a hallucination. And so it'll just make something up, and it probably won't be what you actually intended it to do. Consciousness. Yeah, perfect. Thank you. Get a drink of water real quick. Apologies. Machine learning. Machine learning is one of those subsets in AI. It is probably the more broad of those subsets. And it really deals with the ability to have machines learn from past experience and improve on their ability to recognize patterns. So a lot, and it really deals with like the learning aspect of.
Yeah, you're getting a little feedback.
It's all good. It's all good. It really deals with the learning aspect, the training aspect. Everything that you need to do in order to get inferences for what you're actually trying to get the outputs that you're actually trying to achieve. So it's all about, machine learning is really all about the inputs. And so essentially you need lots of large data sets, and you need various algorithms to achieve a sufficient learning that can inference something that's going to give you the result that you want. So going back to accidents, and you essentially do what's called supervised learning. And I might be jumping ahead on this one as well. Let me get on neural networks. Can I go back one more? Neural networks. I covered large data sets, access to data, and I covered algorithms. I'll go a little bit more into detail on algorithms in I think a slide or two, but neural networks. Neural networks are the way that you essentially save the state of the system as it's training. And why they call them neural networks is they essentially work a lot like the human brain. And computers do something very similar as well. It's basically a bunch of on and off switches that are configured in a certain way in order to produce some result. So your brain has neurons, and as you have memories, have things that you learn, you light up certain parts of your brain and create a certain state of your brain based on neurons firing or not firing. And neural networks work the very same way. They are large networks of interconnected neurons that are essentially have an on or off state in order to determine the patterns that they've previously seen and understand kind of where they need to go to. But there's a lot that goes into that to make sure that you don't do things like, giving it the wrong type of learning, I'm trying to like not use, it's called like overfitting or underfitting. And so you can end up like you have to do a lot of tweaking of the parameters in order to get to where you have something that's useful. So, perfect. This is where we go. Okay. So when I was talking about how I was doing, convolutional neural networks, and I was trying to determine whether something was gone wrong, I was comparing photos against photos. Essentially what I was doing was I was labeling the photos. I had photos that were in a folder that was labeled accidents, and I had photos that were in a folder that were labeled as normal operations. And this is what was considered supervised learning. I was essentially putting in the details for the model in order to understand what it's actually trying to predict. So I labeled everything and then showed the model in a training phase, all the labels, and then I went through a validation phase where I gave it a certain subset of that data and tried to get it to predict in that validation phase. And then you go through what's called an evaluation phase, or a testing phase, and that would be on the next slide as well. But, did too quick. But that covers really what supervised learning is. You're essentially just providing some level of human interaction prior to the training so that it can understand what you're actually trying to get it to do. Then you go into unsupervised learning. Unsupervised learning, and I'm surprised I'm actually trying to remember some of these examples from my notes, but unsupervised learning is you can take it as, say that you've been given a box of toys, and nobody's told you what to do with that box of toys, but you need to you're trying to figure out what it is you're trying to do. So you may start to look through this box of toys and start to sort them by colors, shapes, or categories, and to try to achieve some level of pattern recognition and understanding what the task is. That's really what unsupervised learning is. And funny thing is, I've always known these three to be the most general ones, but I found another one that's called semi-supervised learning, and I think it's more or less kind of like humans interacting with that throughout the whole process, even after the kind of training phase. So it didn't come up all the time. It was just kind of funny that it was a new thing for me to learn. But reinforcement learning. This one's probably the most interesting because you're essentially putting an agent in an environment, and what I mean by agent is in a machine learning algorithm, and you are giving it a set of rewards. You give it a reward function, and you give it, or you can give it a penalty. You don't really have to have the penalty. It just depends on what you're doing and what you're trying to achieve. But you can think of this as if you've never played a video game before in your life, and you start a brand, you put the game in the console for the first time, pick up the sticks, and you just have to start figuring it out. And really, the way that you figure it out is you understand how a point system works. And in reinforcement learning, it's the very same thing. You put an agent in an environment, you give it a way of awarding points or subtracting points, and this will determine how it learns within that environment. Yeah, here you go, next one. Ooh, that's weird. Interesting. It must be trying to cram on the slide. So this goes over the way of it's a brief overview on how to train models. there's quite a few other steps that can kind of go into this process, but I tried to break it down in the most general way. And so first, you kind of go through a pre-processing phase. You take a set of data, if it's structured data or it's unstructured data. If it's structured data, you can pretty much go straight into the splitting of the data phase and start kind of continuing training. But if it's unstructured data, what I mean by unstructured data is that the data that you're dealing with comes from a lot of different sources, and it's all structured in different ways. And in order for you to get a large data set that makes sense for the model, you have to do some type of pre-processing on that data in order to get it into a structured format so that it makes sense as it's going through the model, or as it's going through the training phase. And typically, when you're doing this splitting of the data, you have a training set, which will be about 75 or 70% of the data at the time. And these numbers can vary, but it's kind of a rough way of how you should split your data. So you'll take pretty much 70% of the data and you'll use it for training, and you'll take the other 15% and use it for validation, and then the other 15% will be more or less for testing and tweaking of kind of the hyperparameters, which will be the last part of this. So hyperparameters, I think I have this on the next one. No, maybe I didn't put it. Oh, you know what? I put it on my notes. Hyperparameters. First time I had to do this. I thought I was going to get all the way through this. Oh, yes.
Those are things like the number of nodes and then the number of layers.
Yes, exactly. Yeah, even more so. I tried to keep it very minimal with like, you're totally correct. Yes, you can have layers, but I didn't want to jump in that far on this. But yes, you have what's called, you have epochs, optimizers, loss functions, learning rates, and epochs are essentially one pass through the data, and then you have optimizers, which are consider what your reward function would be. So essentially you can have different optimizers that perform the reward functionality, and these are just basically like mathematical proofs that come from statistics. And so this is like the part where you have to be like, I'm not a machine learning engineer, but I haven't gone and learned the statistics behind this. But you can really take a lot of the code that's already out there and just learn how to run it and then try to extract your own ideas from it. But you also have loss functions. Loss functions are not really tunable parameters. They're essentially the rate at which data gets pulled out of the data set that is thought to be irrelevant. And but all of the other ones are essentially parameters that you can tweak in order to get a better output from your model, and you try to reduce the loss function or minimize the loss function to as much as possible in order to get more data in the actual pass through your epochs each time. Gotcha. So let's go ahead to the next one. All right, perfect. Now we're getting into the fun stuff. So let's talk about autonomous agents. These are all of the. Let's talk about the best way to put this is there are agents inside of a self-driving car that are essentially just systems talking to each other and passing messages based on what their function is, and in order to determine a master kind of like decision process. So agents are. This is probably one of the most the easiest way to understand how it's working is there's tons of features in your car that essentially have to pass off messages to each other in order to perform self-driving functions. So you can have object detection algorithms that are running and looking at objects. This is object detection algorithm where it's circling images inside the photos, and then you can also have like a convolutional neural network that's laid over that to determine, is something wrong? Is there a truck in front of me? Is there people in front of my car? Something like that. So all of these agents, autonomous agent systems are talking to each other, but this is where we're starting to get to, and this is probably one of the most interesting parts of the LLM process itself, is we're getting to a spot where who's heard of AutoGPT? Okay, cool. So AutoGPT is essentially an LLM, but what you end up doing is you chain outputs into the inputs of other agents. And you can create what's called a chain of thought reasoning process. So you can go on ChatGPT and kind of experiment with this yourself without jumping into something like AutoGPT or Super AGI or Baby AGI, if you've heard of those. And what you're doing is you say, hey, based on this input, what is an observation that you make about the input? Okay, now create a thought process based on your observation. Okay, now based on your thought that you created from that observation, what is the action that we should take? And so you essentially take one output and put it into the input of another. They call them chains. And essentially these autonomous agents kind of iterate over and over and over again to optimize whatever the task is that they're trying to achieve. These have been they've been used kind of in healthcare for a little while now. Can't get into too much detail on how those all work because they're very sophisticated systems. And, but they could be used for a lot of like diagnosing diseases, monitoring patients' health. I hope I'm not getting too far ahead of this, probably in my notes, but one of those would be like, has anybody heard the story of the gentleman that had an Apple Watch saved his life because it diagnosed an undiagnosed heart malfunction, and his Apple Watch basically saved his life because it monitored his health, and he hadn't gone to a doctor that had actually like diagnosed him with that heart condition. So that's kind of one of the ways that it's being used in healthcare, and also in kind of like, this isn't more or less an autonomous agent. I might skip that part, but in healthcare, they use convolutional neural networks when you're dealing with cancer. Like if you're dealing with an MRI machine and trying to determine whether, using that to determine, hey, does this patient have cancer compared to a patient that doesn't have cancer? That's one of the other ways that it's used, but that's less of an autonomous agent. So, next one. All right, so this is one of the cooler aspects that's come out recently is researchers essentially took a bunch of these autonomous agents and then gave them all their own personalities in a virtualized village. And what they did was they scheduled a Valentine's Day event, and these agents essentially sent out invitations to other people in this AI village. They essentially asked each other out, and they coordinated to come to an event. And what they were actually trying to prove is what these autonomous agents could do when they're running on themselves or running by themselves. And one of the cooler use cases I've seen by somebody doing a proof of concept of this is they built an automated hedge fund with this type of agents. They essentially had a research analyst that would look for opportunities in the market, and then they would pass those on to a quantitative trader that would essentially assess those opportunities in the market and then determine what they should do with those opportunities. And then that would get passed on to a portfolio manager and figure out how that should be weighted into that portfolio or not. And that was probably one of the coolest aspects that I saw. And I think this is kind of where we're going is you won't have one agent that kind of comes and does everything. You will have individual agents that perform their own tasks, but then hand off those tasks to another agent. And that's kind of what I really want to dig into. But for the next one. Okay. Okay, so AI and ML in everyday life. So most of these you've already been interacting with for a number of years now. Siri and Alexa are basically LLMs, but they've essentially been productized and then built by Amazon and Apple, and they're not as good because if you try to do text-to-speech speech to text on your phone, it's definitely not as good as ChatGPT. In security monitoring systems that are currently use a lot of comparisons between like what they've seen in vulnerability attacks before, and then trying to look at current infrastructure, and then trying to provide suggestions on how to create fixes inside of that infrastructure. Another one, shopping recommendation systems. Things like Netflix, those things have been around. In the 1998, Amazon was one of the pioneers of these types of systems. And in 2006, Netflix was kind of brought that into more advancements by holding a Netflix competition, and they had it was an open competition where they had developers come in and try to best their algorithm, and they paid the winners like $1 million, which was really cool. That was in 2006. And then healthcare and medicine, I kind of touched on a little bit already, but it's been, I guess, more or less in the recent couple years, been using it for like more of like drug discovery, and then they have like, you've heard of AlphaFold, that's been a newer one, that's been pretty cool to try to create new drugs. Good, go to the next slide. Okay, and this kind of touches a little bit back on what we've already talked about. But these systems are going to proliferate in pretty much all the software that you know that you already use. Predictive analytics and forecasting will be used in finance, probably in meteorology, already being used in those as well. Automated custom support, that's been around for a while. It's probably getting more and more advanced now just because there are better models to do a lot of this inferences. And manufacturing, supply chain optimization, using a lot of these like object detection algorithms to look for inefficiencies in the manufacturing process, and then trying to optimize those and remove the human entirely from that process. Autonomous vehicles, I think we can all kind of understand that there's a ton of technology that goes into those. Chatbots and virtual assistants, it kind of goes back to automated support. And then content personalization would be on the recommendation side, the Netflix apps that will recommend you, what your favorite shows are compared to what you've previously been watching. We can go on to the next one. So, early disease detection. Sorry. So this has been around for a while. It's been used like from cancer to heart disease, and more or less more recently it was used for a lot of COVID and COVID spread and trying to predict on how COVID might spread through individuals, and that was another interesting aspect. I remember when that was coming out, there was a lot of data being shared by different people in different areas trying to understand and predict how the spread of COVID would happen. And that was a really cool way. It was a really interesting kind of collaboration between everybody in the field trying to understand how that would happen. Disaster response, there's plenty of technology that's in satellites that monitor certain areas and try to predict how certain things will occur, and then try to mitigate the risks and the response times from those types of events. And then climate mitigation goes really into that as well. And we can go ahead and move on to the next one. All right, so one of the most interesting things about AI and blockchain is there's a lot of questions around the transparency in AI. And there is a lot of things that blockchain can do to solve these problems, because essentially we use blockchain in order to collaborate with other parties that we may not trust to create a transparency between those parties. And so I think that it's not really too apparent at the moment, but I think we're going to see a lot more technologies trying to blend these two, or a lot more companies trying to blend these two technologies in order to kind of get that level of transparency and the decision-making process that these AI agents will be doing in whatever it is that they are trying to achieve. Let me see if I missed anything on that one. Yeah, so AI, I mean, blockchain is more or less going to make a lot of these AI systems more transparent and a lot more secure. And I think that Web3 is probably one of the things that it's much, the answers in Web3 are not as in front of you as something like AI. You can see millions of solutions everywhere you look for AI, and Web3 has been a lot harder to pin down. And so I think over the next 5 or 10 years, we'll see a lot more of those integrations, and it'll make a lot more sense for what we end up, the apps that we use, and try and get more of our data back. We can go ahead and skip the next one. Okay, this one's probably a little bit easier. How do you get started in your AI and ML journey? Honestly, everything that I've done has always been learn by doing. I didn't really ever read any books about these. I didn't really take any Coursera's. I didn't really ever do any Udemy things. I really just spent as much time as I could reading documentation, watching YouTube videos, and then trying to implement those. And a lot of it was trying to figure out what tools to use. So if you're newer to kind of the development space or you've been playing around with code, I'd highly recommend checking out Google Colab. It's a Python runtime in the browser, so you don't need to learn how to go set anything up on your own computer. You can just take Python code, throw it in this thing called like a Jupyter notebook, but it allows you to run Python code in each block of the code and then see the outputs. And so if you're just trying to get up and going and learn things, and you're tinkering around with Python, I highly recommend checking out Google Colab and reading documentation and then taking that code and then trying to make that code work. Even if you don't understand it, if you start putting it into action, you will learn something, and it really just goes down a rabbit hole from there. You'll end up doing something, and it's the same. You get the same reward from accomplishing a hard level on a video game. But yeah, there's tons of books out there. I highly recommend probably buying one of them and then just reading it and then just trying to leverage that against what you're doing on the side, and then trying to understand it as a more in a low level way. And then obviously you can just sit on ChatGPT and interact with it as much as possible. I think most of us are probably going to want to have some level of interactivity, and so I highly recommend, if you're not already, which sounds like most of you are, checking out ChatGPT, going through all the functionalities that it has to offer, checking out all the plugins that it has to offer, and also checking out the playgrounds and the APIs that they have to offer as well, because there's a lot more to learn just that's not, besides just using the ChatGPT interface. All right, and then ChatGPT is called, it uses a process called reinforcement learning and with human feedback. And essentially they allowed the model to give them answers, and then as they were training the model, they would say, okay, well, these are the more optimal answers. Use that in your next iteration of your training. And it kind of became this, like, it's a lot newer to me as a subject, because I'm not as familiar with how these models were trained, up until like a couple months ago. But it is a very interesting aspect and more collaborative training that I've seen than the other three that were mentioned. All right, so I guess we'll jump into the actual ChatGPT part.
Well, we're saying that to the end.
Oh, okay.
You go to your conclusion.
All right, yeah. So I mean, this is. Yeah, I mean, I don't really have anything to say for the conclusion. I mean, it's definitely an interesting landscape. I'm super excited about it. I'm sure you guys can all tell. And I highly encourage you to not be afraid of this technology. I think that it is definitely an amplifying technology. And I believe that, we're humans and we need the assistance of this technology to kind of make our lives better. So yeah, I highly recommend, if you haven't tried just coding something together, try it. It's very interesting and it's very rewarding to do. That's really all I have. Thank you guys for listening to my presentation. Stay there?
Yeah, stay there. You're not done talking.
Not done talking. I definitely need a drink of water.
Yeah, go for it. All right, folks, we're going to transition to the panel. If somebody wants to go use the bathroom, maybe grab some pizza, we'll start in just about 5 minutes, okay?
Different company, you working for a non-government? You guys hear me? Testing.
Testing, mic check, check.
Can hear you.
Cool, thank you.
Hi, Shai.
Hey there. Let's see. It's so weird to see yourself in the room. So Alex, where are you at? I'm in Pennsylvania.
Just outside of Houston, Texas. And I guess we're both in Dallas.
Nice, yeah. So I'm out in just an hour northwest of Philadelphia. So
Excellent.
an hour later than you guys here.
Oh, thanks for sticking it out.
No, it's fine. I thought it'd be fun on a late Friday night.
I'm gonna mute myself until we're ready to kick things off here.
Yeah, same here. I'll go for you too.
Okay.
Testing, mic check. Nick, testing. Testing, mic check. Check, check, check.
Can still hear
Testing.
you.
Yeah, Nick said to try to see if it worked. All right. He says we're good. Mic check. Nick, come in. Bogey, this is Roger in the quarterdeck. Bogey on your 6. I'm going to cause Nick some PTSD here. Bogey on a 6 with a 4 to your left. Come in. Sergeant Nick. Alex, for background, I was in the Navy. So there's a long history between Nick and I of bantering jokes, for lack of a better word.
Very good. All I know is semaphore, or
Semper Fi?
alpha, beta. Yeah. No.
Oh.
I've not been in the service. I respect it, but I did not.
Let's see. Yes, and Nick, I'm still talking. He's texting me. I don't think he hears me. Yes, mic check. Nick. Hello.
10-4.
Nick, you're going to have to let me stop talking. That's more of the problem. Nick. Come in the room. He's messaging me on Telegram to keep talking, so that's why, Alex. Sorry.
Olha que coisa mais linda, mais cheia de graça, bela menina que vem, que passa, doce balanço, moça do corpo dourado do sol de Ipanema, seu balançado
So we could get some hold music going.
é a coisa mais linda que eu já vi passar.
I wonder if that's Nick. That's a nod to Full Metal Jacket.
That's me.
Oh, it's your music. Okay. Thank you. My parents used to play that. I have no idea what it means, though. I think, Alex, do you know what it is? Are you speak French?
I believe this is Portuguese. And
Oh, it's
a
Portuguese.
Brazilian artist, Anton Carlos Jobim. This is the girl from Ipanema.
Okay.
So the chorus is in English.
When she walks, it's like a samba that swings so cool and sways so gently that when she passes,
Let's see. Testing, Nick. Come in. Nick, come in. Earth to Nick. Talking. Let's see. No, they're still getting it set up there. We shall see if they come on.
We are like live on LinkedIn, by the way. Everything we're saying is broadcasted, just so you know.
It'll be fun. Be careful what I say.
So you have an interesting background, Shai. I was reading about your recent initiative with Kalman's Forge.
Yeah, that's what I put the name underneath there. It's actually pretty fun to. I just launched it this week, and so it's a venture studio. Really building this week from scratch, building the public. Hoping to kick off a couple of initiatives this year, over the next couple of months. Actually, roll about 10 products over the next 3 years, and then work with the ecosystem to really incubate a lot of really cool projects that are out there and protocols that are out there. So really just getting started right now. I'm really building things from scratch and excited to get going. So you're going to see a lot more coming next month or two.
That's awesome. And for those who are uninitiated, myself included, what is a venture studio? Like, what is the implication there?
Yeah, sure. So I try to figure out the right business model for a long time, but the short of it is the focus is really on building the underlying primitives in the space. And so the venture studio looks at it in really two ways. One way is, how do you really accelerate the ecosystem? How do you develop the primitives? And so that's kind of the back office, if you will, right? Building partnerships, helping identify projects where the technical initiatives that they need assistance and help in, connecting them with people that can build and do the development, eventually building our own development teams as well to help take on some of those initiatives. And then on the front of the house side of this thing, the idea is really building the mechanisms and the tools to help accelerate that. Well, the way to test out those mechanisms and those tools is by building the products ourselves. And so the other part of the studio is building out initiatives and products within SaaS tools, particularly in large language models for interviews, for creative things around the creator economy, tools for the supply chain. And so that's the basic model of the two. And then really a lot of it's driven around education. And so you're on the very bleeding edge. You're developing a lot of the technology. You're developing a lot of the primitives. And so you deliver a lot of the education out to the community and to the rest of the ecosystem. So that's a quick overview as we're still putting things together.
So cool. So cool.
Thank you. I'm excited to build the partnerships. That's the part that really excites me, is kind of like, as I look at these different initiatives and these different products, they're really just a part in the overall journey, right? And so the overall journey is really about building the partnerships, really building the ecosystem. So doing awesome stuff like this with Web3 Earth and everybody else.
And Web3 is really great for that, isn't it? In putting a signal out and building in public and finding like-minded people who are motivated to solve problems in the world, and that there's different ways of organizing activity and creating teams.
Yeah, that's one of the reasons why I called it a forge, right? Because that's kind of the structure I think of always, is this idea of like people coming together. You're coming in to build tools at that primitive level. You're working together really hand in hand. You're collaborating really closely, and then ultimately you're building that future together, right? You're forging that future together. So that's really the core of what the goal is. And then Kalman is my father's name. And then the really relationship to Web3 overall is this idea of, Web3 is kind of new revolution, innovation that we're building, and we're still defining a lot of that. And so I'm looking at the tools and the stack that we're building is really about defining what Web3 means, right? How AI and blockchain work together, how the machine learning part comes into with the AI as well. We're going to talk a lot about that in this panel. So I don't want to spoil anything there. That's going to be some exciting stuff, right? But that's what I'm looking to do, is really build to define what that is and really help enterprises understand what Web3 is with those technologies.
Very
So
cool.
that'll be exciting. Let's see. How about you, Alex?
I am decidedly less technical, but I come to Web3. We cannot hear you, Nick.
What's the coming up from the not technical side? What's the part that brought you in?
So I would
Another
say
Nick?
that what initially brought me into work with blockchain and AI was actually my interest in mental health. And I decided to go back to school in my 20s to study something called music therapy, which combined two kind of core interests that I had, which were music and mental health and technology. I've always been interested in technology. And when I say I'm not overtly technical, I just, usually spend time on the user side, the marketing side, researching different use cases for technologies that could solve complex health issues. So that a lot of my work has actually been in applying generative media and other machine learning technologies to healthcare problems and more recently cybersecurity issues, different initiatives for charities. So chiefly, I would say my experience over the past 7 to 8 years has been as a product manager to help coordinate teams
Alex, can you hear
around
me?
solutions. Yes, we
Yeah.
can hear you.
Oh, wonderful.
All right.
Bit of a neck on neck. Oh my. That was mighty interesting.
Can you hear me?
Yeah. We're good.
Echo?
No.
The audio from the TV is feeding back into the microphone.
Yeah, I know.
Well, the problem is, you need some way to hear us, and we need some way to hear you. You scaring me?
Yeah.
Can you guys talk quick?
Yeah. Hey, Nick. Nice to meet everybody in the room. My name is Shai.
Waving your face.
Flail around.
All you do is laugh.
I'm calling from Pennsylvania. Save me. I'm lost.
Huh? You can talk to me, I guess. You guys try to talk again. You guys talk again. All right. Guys, we're gonna do a Google Meet so we can end the live stream.
Okay.
I'll text you the link. Yeah, we're you guys, Ryan and Ben are gonna answer your questions. I'll figure that out, okay?
Anyone on the AI